Hello everyone, welcome back to the series Object-Oriented Design Patterns. In this particular video, I'll walk you through strategy pattern and its implementation. What is strategy pattern? A strategy pattern encapsulates all the changing behaviors into separate entities and compose them in the main code or main class. Frankly, this definition doesn't make any sense because we get nothing from this. So let's look into a small simulation to get better idea. So think of this is the main object, the one which interacts with the user when user sends any request through the UI or the application. These are some of the behaviors of type 1, that might be any type. These are couple of behaviors. All are enclosed into a layer of abstraction like an interface. Similarly, we have also type 2 behaviors. Now, when there is a request from the user to the main code, the main object will choose dynamically from this set of behaviors based on the user request. So this is what strategy pattern is. The encapsulation of all the changing behaviors into their respective abstraction layers like type 1 and type 2. The strategy pattern provides runtime flexibility. That means, based on the user request, the main object will choose the particular behavior from type 1 and type 2 at runtime. Let's build a small game like simulation game. So this is called SimUDuck. In this particular game, user will first select the type of duck he wants to simulate. So there are wide varieties of ducks available in this game. Some of the names are marlet duck, domestic duck, and so on. So when user selects a duck, it starts the simulation. Like it makes sound and it keeps on swimming on the screen. It's simply a simulation game. Let's try to build it from scratch. Let's start building the SimUDuck game. For the start, I have added some requirements. Let's go through these requirements. First, our game should support different varieties of ducks, and all the ducks should have swim and sounding properties. And these are a couple of examples of the ducks. One is mallet duck, runner duck, etc. Now let's build the SimU game. First, to build this, the obvious entity we need to have is the duck entity. And each of the ducks should possess two properties. One is swim and another one is sound. These are the two properties that the duck will possess. Now let's build the concrete classes. I mean different varieties of ducks. The class mallet duck will inherit all the properties of a parent duck class. The display method in the mallet duck will simply greet the user, "Hey, I'm mallet duck." Similarly, we have other ducks. So far, we have two concrete ducks, like we have mallard duck and runner duck, and we have the parent duck class with two properties, swim and sound. Let's run this SimUDuck. First, we need to import the script. Now, the user will select any one of the ducks. Think of user have selected mallard duck. Oh, sorry. We need to use sim. Now, the mallard duck has been stored in the variable duck. Let's see if we can display it. Yes, it is greeting quite nicely. And will the other methods, I mean the other properties will work? Sure, both of these are working. We got a new requirement of adding another behavior to the ducks, that is fly behavior. So how can we add a new behavior into the duck? We can simply append over here with the fly method similar to swim and sound. Fine, so far so good. But think of in the wide varieties of concrete ducks, there are two ducks, namely rubber duck. This is a simple toy. What we find just simply a rubber duck. And also a wooden duck. So these are the two toys, simply toys, which have been added into the wide varieties of ducks. Let's try to run the simulation again with the new varieties. Since we have made some changes in the SimUDuck script, we need to restart the interpreter. Now let's import it again. So this time the user have selected rubber duck as his choice. Let's see whether all the behaviors are working fine or not. Yeah, it shows that I'm flying, but in reality, does rubber ducks fly? No, these are just toys. They cannot fly. Now, what do we do? Because this is a problem. Uh, the rubber ducks cannot fly, but we cannot display that these can fly. So what can we do here to solve this issue? So far what we understand is there are multiple flavors of the behaviors. How can we overcome this issue? Since we are using inheritance, this fly method will be given or will be inherited to all the concrete ducks. The other ducks like mallet duck, runner duck will fly eventually, but a rubber duck and wooden duck they cannot fly. So this is where strategy pattern comes into place. So these different kinds of flavors in the behaviors will be moved out of this class and encapsulated into separate entities. Always remember a phrase, pull out what varies. I mean, decouple all the behaviors which are changing. In this particular case, the fly behavior and the sound behavior also are changing. The wooden duck cannot sound. Maybe the rubber duck sound differently rather than quack and quack. So these two behaviors, what are varies based on the concrete classes. For this, we need to decouple them and encapsulate into separate entities. Let's implement strategy pattern on this particular case. Let's create another file uh, for behaviors. So we need to remove these two methods from here and we will implement in behaviors. Let's see how can we implement this. Let's start with the fly behavior. So to implement fly behavior and its different kinds of flavors in it, uh, we need to start with the interface. ABC stands for abstract class. We also need a decorator abstract method. Yeah, and we'll create an interface. So in this interface, we'll have only one single method called fly. Sorry. Uh, this is an abstract method, so there will be no implementation for it. What are the different kinds of flavors we have in fly behavior? We have a duck can fly or a duck cannot fly, like rubber duck and wooden duck. These cannot fly apart from all other ducks which can fly. So we'll create uh, all the classes for the different flavors. This class will be implemented on top of fly behavior. We'll just simply return I can fly. Similarly, we can also implement cannot fly math cannot fly concrete class. So why do we need interfaces over here? Because interfaces provide a layer of abstraction for the concrete classes. So the interface will group all these concrete classes into a fixed group called fly behavior. Okay, let's implement the other behavior called sound behavior. This is also an abstract method. In this sound behavior, what are the different kinds of flavors we have for the ducks? One, a duck can make a sound, or a rubber duck can make a different sound rather than a real duck. And a wooden duck cannot make a sound at all. So we need three flavors. So this is for all the live ducks. So this class will be implemented on top of sound behavior. Similarly, we have other flavors too. I hope you got the idea. This is the sound which is made by a rubber duck. A wooden duck cannot make any noise, so we return nothing, an empty string. By this, we have implemented all the two behaviors of fly and sound. This is how we implement an interface and all the concrete flavors for the behaviors. Now we can use these flavors of these behaviors in the main code, I mean in the ducks. For that, first we need to import the script. Next, we declare two reference variables to hold these behaviors of fly and sound. One is fly behave, which will hold the types of fly behavior. Behave. Another one is sound behave. And to perform these behaviors, we need other two methods which are called perform fly. This is a handler method. This is just used only to run the fly behave fly method. Oh, I think we need to use self. Behave. Now this should work fine. Similarly, uh, we also need a method for sound. we need to assign the fly behavior and the sound behavior for the ducks, I mean the concrete ducks. There are a couple of ways to do it. Let's go one by one. So here the mallet duck is inherited the duck parent class. That means these two variables will be there in mallet duck and those will be none. We need to assign mallet duck fly behavior and sound behavior to these variables. Let's see how can we do it. So we can simply uh, change self.fly behavior to what is the desired fly behavior for the mallet duck that the mallet duck can fly. That is simply can fly class. We'll assign this fly behavior to the mallet duck. Similarly, we do the same thing for the sound. What is the sounding behavior for the mallet duck? It makes the sound quack. We can do the same thing for all the other ducks. I have added all the necessary behaviors for all the concrete ducks. If you see rubber duck, the fly behavior is the duck cannot fly, and the sound is it can make the sound squeak. Similarly, I have added to wooden duck. Now let's run this and see if everything is working fine or not. First, we do the import. Now, um, let's start with the mallet duck. Let's look at the greeting. Yeah, it is working fine. Let's see the fly and sound behaviors. It is the perform fly method. I think we need to use return here because the self.fly will return a string from here. So we'll carry forward it. Yeah, that's a small. Now I think this should work. Let's do this again. Yeah, you can see now it worked. Similarly, let's try the sound method. It can make the sound quack quack. Now let's try to use rubber duck. We'll try to use rubber duck. For that, we can use sim dot rubber duck. Let's try to see the behaviors of a rubber duck. If you see the rubber duck behavior of fly is returning I cannot fly. This is the right behavior for the rubber duck. So the sound behavior giving squeak and squeak. So this is working fine. This is one way of assigning the concrete behaviors to the concrete ducks. I mean, we are assigning can fly concrete behavior to the mallet duck. This is one way. There is another way. Let's talk about what are the cons of using this way. So the cons are we don't have runtime flexibility. If an user want to change the fly behavior from can fly to cannot fly at the runtime, they cannot change in this particular design. Then what is the other way which will satisfies the runtime flexibility? Let's look into it. I have removed all the static assignments of the fly behavior and the sound behavior in the ducks. Now let's define a setter method. Set fly behavior. This will take an argument of fly behavior from the concrete fly behaviors. This fly behavior variable or the argument is of type fly behavior. Now we will assign this fly behavior to the class variable fly behave. Similarly, we also add another setter method for sound. This is of a type sound behavior. This will also do the same thing. Now let's try to run this. First, we need to import SimUDuck. Apart from SimUDuck script, we also need the behavior script. Let's try to run the simulation on one of the duck. Let's take mallet duck. This is from SimUDuck. Okay, let's see what this will return by display method. Okay, fine. Let's try to use the fly and sound behaviors. This will throw an error because we haven't yet set any of the fly behavior to this particular duck. The mallet duck fly behavior for now is none. That's why it is throwing an error. So we will use set fly behavior method to set a fly behavior to the mallet duck. Let's see how we can do that. So for this we just use duck dot set fly behavior. In this we'll pass an argument, one of the behaviors from the behavior script. We know the mallet duck will fly, so we will use can fly class. Now we have set the behavior of the duck to can fly. If now we can try to run the perform fly method, it can fly. If I want to change the behavior from can fly to cannot fly, I can do that at runtime. So let's try to run perform fly. So if you see, I am changing the behaviors of the duck at runtime without changing anything in the script. This is called runtime flexibility. So in strategy pattern, we use this kind of setter methods to satisfy or to obey runtime flexibility. To conclude, there are two main things in strategy pattern. One, always pull out what varies into separate classes. In this particular case, fly behavior and sound behavior will keep on changing based on the concrete ducks. That's why we have pulled them out from the main code and set them into separate entities. That is one point. And another point is always lean towards runtime flexible designs. So we use setter methods to satisfy runtime flexibility in strategy pattern. Where can I use strategy pattern? Places where payment processing, data compression, and serialization will happen. There are so many examples where you can use strategy pattern, but these are some of the application examples. One go-to question you should ask whenever you want to implement strategy pattern is, if there are a set of algorithms which needs to be implemented, then you should definitely go for strategy pattern. With this, we have come to the end of the video. Thank you so much for watching the video. If you like anything about the video, please do add a comment. I'll see you in the next video. Bye.